Welcome to the third example in our WinderCAM tutorial series. Today we'll be winding a short vessel.
The short vessel is interesting because it isn't a typical cylinder. The winding period is close to 2 pi, meaning the reinforcement pattern is single loop. Only one fiber band is wound per revolution.
Step 1. Defining the mandrel geometry. We import the contour, the vessel's generatrix. We specify the polar opening radius, total length, and maximum diameter. WinderCAM uses this data to build a 3D model of the mandrel.
Step 2. Configuring winding parameters. Here we select the roving width, number of turns, required thickness, and winding angle. The software uses Clairaut's equation to determine a stable geodesic path.
Step 3 is the preliminary winding path calculation. WinderCAM computes the geodesic path based on the mandrel geometry. You can see the winding curve on the 3D model. This initial approximation doesn't ensure complete band coverage across the entire shell surface.
So we need to refine the paths. That brings us to the correction stage, right?
Exactly. Step 4. Winding path correction. Here we ensure uniform coverage for a smooth, continuous layer.
Shells with a winding period close to 2 pi present a specific challenge, the polar region.
Indeed. Since the tape returns to the same point near the pole after each revolution, material tends to accumulate there. To prevent this, one option is to shift the subsequent layer by an angle equal to 2 pi divided by the number of layers, n. This distributes the material around the pole opening.
And what about the transition between different winding patterns?
That's the sixth step, the transition turn. Reinforcing the structure of a short vessel often requires both helical and hoop layers on the cylindrical section. A transition turn is necessary to ensure continuity during the automated winding process. Calculating the transition turn is not yet within WinderCAM's capabilities at this stage of development.
Once we have the adjusted path and the transition turn, what happens next?
Step 7. Calculating paths for the winding equipment. This stage is machine-specific. WinderCAM takes the path on the mandrel and converts it into motion commands for your winding machine's axis. The program calculates the motion while minimizing acceleration.